Okay, let's talk about binomial distribution formula. So this is a binomial distribution formula. And I know that it looks a little bit complicated, but it's not really, I'll show you that it's not really complicated. So let's say the probability, right? No, so for example, our assumption is that the random variable x is what? Binomial variable. So that's our assumption, right? And that's why we can use a binomial distribution formula. So the probability that x is the random variable, binomial random variable is, let's say, value of small x, some value, given there's n is a sample space and the pi is the probability of interest. Is equal to n factorial and x factorial n minus x factorial. By the way, this is small x, the small x. And then pi, the probability of interest, small x, power to the small x. And then 1 minus pi, and then n minus small x, right? By the way, as you notice, this is what? This is the formula for the accounting. So we can rewrite this as cnx, or sometimes people use this notation. Okay, so if you rewrite this, basically cnx multiplied by, cnx, and multiply by pi x 1 minus pi n minus x, right? The same thing. Okay, now, so I'll just give you the example. The example is, let's say we flip a coin 4 times. So I'm using this example, right? So to flip a coin 4 times, so let's say flip a coin how many times? 4 times. 4 times. And so in this case, so if you want to find, let's say, probability of, so, and then if you want to find the probability, so you know that x is a random variable, right? X is a random variable, the binomial random variable, so binomial variable. So if you want to find and then find the probability of having 3 head when you toss your coin 4 times. So 3 head. So let's say x is random variable, x is binomial distribution, and then the small x is 3 head. Okay, the 3 head. So you know that this is the binomial variable. And the given, so the sample space, so you toss 4 times, right? So n is a 4, right? And the head is our event of interest. So the pi, the probability of event of interest is half, right? So the pi is 0.5, because when you when you flip a coin, right, the probability of having head is 0.5, half. All right, so that's why the probability of event of interest, the probability of having head, is always half. So that's the your formula. So this is like represent the cases like 3 head, right? So when you flip a coin 4 times, like for example head, 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 and tail, or head, tail, tail. Oh, sorry, head and head, and head, 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 or tail, and etc. Right? So what is the probability? So if we use this formula, so n factorial is what? 4, right? So that's a sample space 4 because you tossed coin 4 times, and x is 3 head, right? Small x is a 3. So this is what? Small x, and 3 factorial, n is a 4 and x is a 3, and then pi is 0.5, so pi is 0.5, so multiply 0.5 to the x, 3, right? And then 1 minus pi, 1 minus pi, and n minus x, n minus x, right? So that is what? 4 factorial, 3 factorial. 4 minus 3 is 1, so 1 factorial. By the way, 1 factorial is just 1. And then 0.53, and then 1 minus 0.5 is just 0.5, right? And then 4 minus 3 is 1, so it's power to the 1. So you can so if you use a calculator, you can find the answer. So you can find the probability. The probability of having 3 head, right? When you flip a coin 4 times, and then you can find the probability using the calculator. Okay, so basically I'd like to know like the formula for the binomial distribution probability, and then I want you to know that what n really means, and the pi, what is the pi, right? What is this small x, right? So this is the example. Okay, so let me just end my lecture here.